Right now, software engineers are dealing with a flood of bugs created by AI coding assistants. Look, these things are great at making features, but they are even better at making bugs. So what are we supposed to do? Well, normally we turn to things like OpenTelemetry or OTel, because that gives us things like metrics, logs, and traces, and that helps us understand which component to focus on. But look, even with as good as these tools have gotten, it still doesn't give you enough information to actually debug the problem. I've been doing this for 20 years. We've taken these ideas about as far as they can go. So what I propose is that we need to actually move beyond observation and into reproduction. That means fast problem resolution and rapid experimentation. Now we have these AI coding agents, and they're supposed to be able to multiply our intelligence. So why don't we give them realistic sandboxes that they can iterate inside? So look, by the end of this video and this broader video series, hopefully you'll see that it is not only possible to expand your observability into full fidelity debugging, but you'll also be able to reproduce production-like sandboxes right on your own desktop and right from within your AI coding assistants, all within seconds. I think this is the next step in the DevOps observability journey, and I think that hopefully you get something out of these videos. So be sure to click on my next video as well, where we'll show you how to do this all from within an AI coding agent, but I'll tell you ahead of time, that one is only for the trusting. Now with all of that, let's get right into installing our recording agent. Okay, now you're going to click next, and some other stuff is going to happen, but through the power of internet magic, because I have already installed this, and we don't wait 30 seconds, I am going to go ahead and jump into my newly created cluster. Now, in the infrastructure view, which is what I clicked over here in the main nav, I see that I currently have no sidecars because it is newly installed. But the fact that it is reporting it all tells me that the operator is running. In the documentation, you can see additional examples to know how it is running. Now, this does many things that you would expect actually from a Kubernetes management tool, like draw you a cluster map of what is in the cluster, like your different namespaces. You can click on them, and in this sort of crowded view here, I can see things like all my workloads, and I see that I have a Java server running here. I can go and click on this Java server, and through the power of remote injection, I can inject the sidecar and actually go and begin monitoring and hit update. Now when you have things like eBPF installed, that's even easier. But either way, it is the same. You just hit the buttons. Okay. Now, once you have this all running, I'm going to show you a more complicated example. In our demo here in the Java app, it'll just show up in the middle. Now, I'm going to show you something more interesting just to see what you would get when you turn on your own app, right? Okay. Now, I have here a demo app called Dev Decoy. It has many services that run and all talk to each other. I have turned on eBPF monitoring on this demo app, and so I'm automatically going to see all of the transactions going into and out of this service. Like I said before, this is better than OpenTelemetry because none of this requires external data ejection, right? There's nothing that has to be exhausted out of the application in order to record this. This is all done straight from the network with low overhead and very low impact. Now, I see that the front end is actually talking to a variety of back-end services, such as MySQL. It's talking to an AI model. It's talking to the Numbers API and GitHub. It has a variety of different things. Now, if we were going to go and try to build a staging environment to replicate this service, we would somehow have to go and mock all of these services. But if you aspire to be lazy in the way that I am, you are not going to do that. And the first step in that is having full observability into the payloads, because that's going to allow us to mock these services and do that next stage in observability, which is reproduction. Now, what I'm going to be able to do here, if I click on any one of these particular RR pairs or request response pairs, is I'm going to be able to see all the details of what happened. Now, some of these might be interesting. I can actually peek into binary protocols like MySQL, and I can get information that was passed back and forth. Okay. Now, in this case, this was actually the API going to MySQL, but we'll find MySQL in a second. Now, when we're looking at things like HTTP, we get Postman-like information, but we're getting all of it, right? And we're getting it straight from a production application. Now, like I said, with binary and MySQL, we can actually click on MySQL transactions, and instead of getting a bunch of binary gobbledygook, we can actually get JSON. Now, The last thing that we might want to do here to complete the observability pipeline, right? We're going to want to start that reproduction process, is we might want to create a snapshot. And that is a moment in time clipped from production, taken with low overhead using the magic of eBPF. We hit that save button and we go and get a perfect recording of production that we can go and use for further debugging and reproduction purposes. But before we do that, we're probably going to want to get some AI some AI help, because we have to use AI for everything, because that's what we do nowadays. But also, it actually has some use here when we go into data like this, because we can use AI like a tennis partner, right? Or we can actually use our AI coding agent to drive this process. Now, I'll show you next. More in the next video, where I take the snapshot and turn it into an automatic staging environment. So click on the next video or look in the links below to learn more about Speedscale. Thank you.